Hi, this is Suchi, and today I'm going to discuss about recursion. So before going into code level details, let us look into the definition from Wikipedia. So in Wikipedia, it says, in computer science, recursion is a method of solving a computational problem where the solution depends on solutions to the smaller instances of the same problem. So what does that actually mean? I will show you more practically. Then it says recursion solves such recursive problems by using functions that call themselves from within their own code. So basically, recursion is nothing but a function that calls itself. Because if we can define a problem with a smaller instance of the same problem, it becomes a recursive problem definition. So let us look into an example to understand this definition more precisely. Let's say a factorial of a number. So factorial is what? Let's say we have 5. So factorial of 5 will be 5 into 4 into 3 into 2 into 1. So a factorial of a number n will be n multiplied by n minus 1 multiplied by n minus 2, and we will keep decreasing the number and multiplying it until we reach 1. So this is the factorial of n. Now if we look into this very carefully, we can see if we just remove this n part, it becomes the factorial of n minus 1. Because this part, n minus 1 multiplied by n minus 2 multiplied by all the numbers up to 1 will be the n minus 1 factorial. So basically, we can define n factorial as n multiplied by n minus 1 factorial. So basically, we are defining this problem, which is the bigger problem, in terms of a smaller problem, but the smaller instance of the same problem. This is also a factorial. So n factorial equal n multiplied by n minus 1 factorial. Let's look into an example. Here we can see 5 factorial is equal to 5 into 4 into 3 into 2 into 1. Whereas 4 into 3 into 2 into 1 is again 4 factorial. So 5 factorial we can define as 5 into 4 factorial. So this is what a recursive definition is. A function that calls itself with a smaller instance of the problem. So let's look into another example. Multiplication. Yes, you heard it right. Multiplication is also possible to define multiplication in recursive terms. How? Let us look into it. So if we look into this thing, n multiplied by m. So let us consider if n multiplied by n is multiplied by m, that means this will be similar as adding n m times. So if we add n m times, it will become n multiplied by m. So we can also say n plus, if this is total m times, so if we remove one n, then it becomes m minus 1. So can we also denote like n multiplied by m equal n plus n multiplied by m minus 1, because this is m minus 1 times if we remove this n. So this is also a recursive definition. That's why we can also denote multiplication in recursive terms. Here you can see n multiplied by m equal to n plus n multiplied by m minus 1. So this is also a recursion. Let us look into an example. Here you can see 6 multiplied by 4. We can denote it as 6 added 4 times. We can also do it in the other way, like 4 added 6 times. But just for our convenience, here we have put it as 6 added 4 times. So if we add 6 4 times, it becomes 6 multiplied by 4. Similarly, if we add 6 3 times, it becomes 6 multiplied by 3. So if we can we consider 6 plus 6 into 3 as a 6 into 4? So we can denote 6 into 4 as 6 plus 6 into 3. So this is also a recursive definition. Any problem that we can solve using iteration, we can also solve using recursion. Let us look into one recursive function. So let us define a function, let's say, and let us have some parameter over here. Let's say n. And if I just print n here, this becomes a function. This is not yet recursive function because it is not calling itself. So to make it recursive, we can do this. Now, let me ask you one thing. If we are again passing n here, what do you think will happen? So as we have not defined anything, as we have not changed anything here, the problem size remains same. So this will be keep printing n again and again, and it will be infinite. So in recursion, we have to terminate this self-calling functionality with the help of some condition. So that is called the terminating condition or the base condition, which is very much important to terminate the recursion. So when to stop, that we need to tell this function. So even if now if you see here we have n, we are doing n minus 1. We are calling it with n minus 1. But it will keep going on and on as we have not defined any criteria to stop. So how we can do that? We can just have some base condition here inside this function, which will depend on the parameter. So let me check. Sometimes it can depend on some other expression, which will be derived from the parameter. So let us see, let us check if n becomes 0, we will stop. A return statement will stop this. So let me do this. And here I will just add a return statement. So it will print n first of all. Then it will check the base condition. If n is 0, it will be returning the function. It will be stopping the recursion. Now let us check. Let me run this cell. Now this function is defined. And if I give 10 here, it will be printing 10 to 0. Let me just show you. So here you can see 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 has been printed. We can even remove the return 0. We can simply return from here. It will be returning none in that case. So here you can see it is not returning anything, that it is just printing these things. So this is how we can stop the recursion with the help of base condition. Now look at the multiplication example. So let us implement multiplication with the help of recursion. And we will pass the first number, let's say the bigger number, and the smaller number. Okay, we will be saying we will be adding this, multiplying this bigger number with the multiplication of big number with small number minus 1. Here we will be having, so if this is the definition, big number and then multiplication of big number with small number minus 1. But again, this multiplication can be performed with the help of this function itself. So we will be calling this function instead. So how we will add that here? So here we had the big number and here we will be having small number minus 1. So this is the recursive definition and we will be returning res. But here as you can see, we are using this res only for returning. So we can directly return from here instead of assigning it to a variable and then returning that. So we can directly add return statement here. So this is the main recursion. But now as you can see, this function is again calling itself. So it is a recursion. So we need a terminating condition. So what could that be? When we will stop. So if let's say 6 multiplied by 4, the example we have taken before, this is 6 plus 6 plus 6 plus 6, 4 times, right? So if we have this, and if we are doing this in the second recursion, 6 multiplied by 3. Again, this 6 multiplied by 3 is nothing but what? This 6 multiplied by 3 is equal to 6 plus 6 multiplied by 2. Again, this 6 multiplied by 2 is nothing but 6 plus 6 multiplied by 1. Now, if we do not stop here, what will happen? 6 multiplied by 1, it will try to do this. 6 plus 6 multiplied by 0, which is okay. But after that, 6 multiplied by 0 is what? It will become 6 multiplied by 0 equal 6 plus 6 multiplied by minus 1. So this will keep doing. This will be continuing for infinite time. Again, it will try to do the same thing for 6 multiplied by minus 1. So 6 multiplied by minus 1 is 6 plus 6 multiplied by minus 2, which is again minus 6. That's fine. The result is correct, but it will keep doing this thing for infinite time. So we have to stop it. Where we can stop it? Here we can stop it where we reach 6 multiplied by 1. We definitely know that this is going to be 6. The bigger number will be returned when the smaller number is 1. So why not we apply the base condition that when the smaller number becomes less than equal 1, not less than, it becomes 1. When the smaller number becomes 1, what we will do? We will just return the bigger number. So if we do this, let us see if it is working correctly or not. Let us run this and let us do this. So it should be 50. as you already know. Let us run this. So here you can see our multiplication results are matching. So this is happening correctly. So this is just positive integers multiplication, which we have implemented here with the help of this recursive function. But here I want to tell you one thing. Our method, our function is not taking care of the negative numbers. If big number is negative, that's fine. But if smaller number is negative, it won't be able to perform this task, because if there is a negative number and if we keep subtracting 1 from it, small number will never become 1 and it will end up with a infinite loop again. So how to deal with that? To deal with that, we need to do few modifications. First of all, we need to turn our base condition till 0. So we will check if it is 0, if small number is 0, then we will be returning 0. Now, if the small number is positive, is greater than 0, then we are good. We will be doing whatever we were doing previously. Let me just change this name. And this up to this is fine. But if it is not greater than 0, if the smaller number is less than 0, that is the else part, where we will say if the smaller number is less than 0, then we don't need to keep subtracting 1 from it. We need to keep adding 1 to it to make it 0. So in that case, if we multiply 10 with minus 5, what it will be doing? It will be multiplying 10 with 5 and adding a minus at the beginning, right? So if we do this, 10 multiplied by minus 5, what will happen? It will be minus 50, which is actually minus of 10 multiplied by 5. That's what we are going to do here. We will do a negation at the beginning and then we will add our thing here. So again, we will be adding this, but the only difference will be we won't be subtracting 1, we will be adding 1 to it, because first time we will be multiplying by this, but the next time we will be multiplying by minus 4 instead of minus 5. So let me just add minus 5 here. Here it will be 2. Our function is resulting incorrect. Okay. There is another problem. If there is 10 multiplied by minus 5, next time it will be 10 minus 10 multiplied by minus 4. Because this needs to become, because this is minus 4, so this minus 10 needs to become plus 10, plus 40. So we have to do a minus here. So here it will be like this. So instead of having a plus, we have to have a minus here. So this one will become a minus now. So now this formula will work. Big number minus the rest of the thing. Now if we run this, let us just run both the cells. Now you can see our result is now matching. So you can see what was wrong here and how we fixed it. So that's all for today, guys. I will talk more on recursion in the next video. Till then, keep learning, keep implementing. Thank you for watching.